All right, here we go, guys. Today we are solving equations. We've done 3 lessons worth of simplifying, and now we're solving equations, okay? There are some ways that solving equations is easier, and one little way that it's harder, because you have to remember to check your answers when you solve square root equations, because sometimes you get what's called extraneous solutions, which mean you do all your steps right, but when you substitute it back in, it just doesn't work. And then in that case, that answer is not a solution. And you'll see that happen. But I feel like last lesson was probably our hardest lesson of the 4. So today should be a little bit easier. All right. So to solve a radical equation, you have to get the radical by itself. And so here are 3 steps. Notice step 1, step 2, step 3. So step 1, you're going to get the radical by itself by adding the 4 and dividing by the 5. And now we have the radical all by itself. Then, if it's a cube root, remember that the inverse operation of cube root is to cube it. So we cube both sides, and that will cancel out your cube root. And then I got 2x equals 8, and then I solve that, and I get x equals 4. Step 3 is the checking step. You have to check. You're going to probably get like 90% of your answers are going to work, but that 10% that don't work, you know that's going to be tested. So you got to check. So check. So I substitute my answer, which was, down here, 4, back in for x, and I simplify, and I get 6 equals 6, which is true. That means my answer checks out. If I got something like 6 equals negative 6, that would not be true. Any questions before we start some problems? Okay. We are going to do number 3, and then I'm going to send you guys back to do 1 and 2. Let's look at 3. In problem 3, I have to get the radical by itself, so I have to first undo the minus 3 with what? Plus 3, good. Plus 3. So I get negative 12 equals, and then this is gone, but I bring this down. Negative 6 times the square root of x plus 4. So all I did was add 3. Now I have to get rid of the negative 6 in front of the radical, and I'm going to do that by dividing, because it's negative 6 times the square root, so to undo that multiplication, you divide. And we get square root x plus 4 equals, I forgot to divide by negative 6, so that negative over negative is positive. Okay, so the first part is just getting the radical by itself. And now to undo a square root, what do I do? No, you're right. Don't doubt yourself. To undo a square root, you square both sides, because square root and squaring are inverse operations. So that's going to cancel my square root and my square, and I get x plus 4 equals 2 squared, which is 4. And then I'll subtract 4 from both sides, and I get x equals 0. Morning. X equals 0. Okay, so I've done steps 1 and 2. Step 1 is get your radical by itself. Step 2 is undo that radical and solve for x. Step 3 is check. Negative 6 square root 0 plus 4 minus 3 equals negative 15. Try not to get into the space of this problem over here. So I just substituted my answer, 0, for x. 0 plus 4 is 4, and the square root of 4 is 2. So now I have negative 6 times 2. Minus 3 equals negative 15. Negative 12 minus 3 equals negative 15. Looks like it's going to work out, right? Negative 15 equals negative 15. So that means I'm going to box up my answer down here, and it checked out, so I can give it a check. All right, any questions on 3? Because I'm about to ask you to do problems 1 and 2. Okay, I'm gonna leave that up, and then you guys go back and do problems 1 and 2. If you finish 1 and 2, you are free to work on 4, but just to give you a hint on 4, it's a little different because you have an x on both sides. So when you get to 4, if you feel stuck, that's okay. We are gonna go. All right, number 1, undo your addition with subtraction. And you have square root of x equals 4. And then what do you do to both sides? You square. Very good. So squaring the left side will cancel out your square root. And then squaring the right side gives you what answer? 16. All right, so that's going to be our answer if it checks out. I'm going to do the check step now. Square root of 16 plus 5 equals 9. 4 plus 5 equals 9. It's looking good, right? 9 equals 9. So box up your answer. Because remember, your answer is not 9. Your answer is 16. And give yourself a check. All right, next one. We have that extra 2 on the outside. Yumna, what should we do to get rid of that 2?
Divide.
Very good. All right, so let's divide both sides by 2. And on the left side, I have my cube root isolated. Cube root 5x plus 7 equals 3. How do I get rid of cube root? Say it again.
Square.
Except instead of a square, what exponent should I use? Very good. All right, so cube both sides. That cube and the cube root cancel out, so I have just 5x plus 7. All right, and what's the common mistake for 3 cubed? What mistake might people write down?
9.
They might write down 9, right? But remember, 3 cubed is 3 times 3 times 3, which is 27. Good. All right, and then we have to just solve for x, right? So to solve for x, we're going to subtract the 7, divide the 5. X equals 20, and divide the 5. Did you guys get x equals 4?
Yeah.
Okay. All right, and we have to do the check step. I'm telling you, like 9 times out of 10, it's going to be good, but you have to check because there will be some that won't work. So checking 2 cube root 5 times 4 plus 7, and that should equal 6. All right, that's 20 plus 7 is 27. What's the cube root of 27?
3.
It's 3, right, because 3 times 3 times 3 is 27. So 2 times 3 is 6, and 6 is 6. So our answer, x equals 4, checks out. Go back and box it up and give it a check. What questions do you have on 1, 2, and 3? Because they're going to be different from the next set of problems. Okay. All right, so we do the same start for this problem. We still have to isolate the square root, and we still have to square both sides, but it's different because we end up with x's on both sides, so we have to do something with that. So the square root's already by itself, so I can start by squaring both sides. So on the left side, I have x squared. And then on the right side, my square root and my square cancel out, so I get equals 56 minus x. When you have an x squared in your equation, what is it called? What kind of equation? Starts with a Q.
Quadratic.
It's a quadratic equation, right? And so we learned a lot of different ways of solving quadratic equations. Some of you guys really love the quadratic formula when we were doing that, but really most of these are most easily solved by factoring. In order to factor, we need to make one side equal what? 0. Good. And I want to keep my x squared positive, so I'm going to end up moving both of these to the left side. So what I'm going to do is I'm going to add x and subtract 56. And I'm going to add x and subtract 56 on both sides. Because I want to move everything from the right side to the left side. so that I have one side equaling 0. So I have x squared plus x minus 56 equals 0. All right, I need now two numbers that multiply to make negative 56 and add to make 1. And I know some of you know them already, but we need to think this through for people who are not remembering factoring that quickly. So negative 56, I'm going to start making my list. It could be negative 1 times 56, negative 2 times 28. 3 doesn't work, right? 4 works. Negative 4 times what? 14. 5 doesn't work, 6 doesn't work, 7 works. Negative 7 times 8. All right, did we find it? Yeah. So this is the pair that multiplies to negative 56, but adds to 1, because I have 1x. All right, so then I'm going to write x minus 7 times x plus 8 equals 0. And I'm getting two answers, x equals 7 and x equals negative 8. And especially when you get two answers, often one or both of them won't work, so we definitely are going to check these. I kind of ran out of space because of my big marker, so I'm going to do my check on a new piece of paper. So I'm going to check them both separately. I'm going to check 7 first. So to check 7, I'm going to do 7 equals square root of 56 minus 7. Seven equals square root of 49. What's the square root of 49? 7. So 7 equals 7. So that answer checks out. Good. All right, we're going to check negative 8. Negative 8 is equal to the square root of 56 minus negative 8. So minus negative is the same as plus, and I get the square root of 64. So I get negative 8 equals square root 64, and I get negative 8 equals 8. Did I not tell you? Sometimes they don't work, right? So even though algebraically negative 8 worked out to be an answer, it's not actually an answer. So we're going to cross this one out and only box this one up. Only one of the answers worked. Do you guys have questions on that? Okay, let's turn the page. Yeah.
Is it possible to get like two answers? Is it possible to get like two answers?
Yes. So you could get two answers that work. You can also get two answers and neither of them works, and then you would write no solution. All right, any questions before I turn the page? Okay, here we go. All right, this looks different, right? Oops, that doesn't look like anything. This does look different. Do you guys remember the 1/2 power is the same as what root? Square root, right? 1/2 power is the same as square root. You don't have to make it a square root though, because we also have a good way of solving these when you have a fraction exponent. But if you get really stuck, you could turn your 1/2 power into a square root. You could. Let's look at this one right here. It's 2x to the 3/4 power equals 3. I've kind of got a hole on top of this, but what we ended up doing was raising both sides to the 4/3 power. So 4/3 is the reciprocal of 3/4, right? So you turn your fraction upside down. The reason why that works is because when you raise a power to a power, you multiply your exponents, and that's going to give me 12 over 12, which is just 1. So raising each side to the reciprocal of your fraction exponent is going to make your exponent just 1, which is not really an exponent at all. And then you end up having this on the other side. And then you can finish, so this one here would finish by dividing by 2. Like that. And sometimes you would write it this way. Sometimes you would write it with a root. So it would be cube root of 3 to the 4 over 2. So you might write it that way, or you might just write it with the exponent. Often you get things that simplify. That one doesn't really simplify that much. I mean, you could take a 3 out for sure, but sometimes you're going to get things where your root cancels altogether. Let's do 7, and then I'll send you back to do 5 and 6. Okay, so let's look at 7. In 7, you have to isolate this part that is being raised to the 4/3, and that's going to be everything in the parentheses. So I've got to get this by itself. What am I going to get rid of first, the 2 or the 4? Want to take a guess? Do we get rid of the 2 or the 4 first? The 4. So when we're undoing operations, we do PEMDAS backwards, and so you get rid of the addition and subtraction first. So we're going to subtract the 4. And then how do we get rid of the 2? Divide, good. Okay. So subtract the 4, divide the 2, and now we have the part with a fraction exponent all by itself. And then I need to raise each side to the reciprocal. So we're going to take that 4/3, flip it upside down, and it's 3/4. So that's what I'm going to put on both sides. It's an exponent, remember. 3/4 is my exponent. All right, so 4/3 times 3/4, that actually cancels out, so you just have x plus 3 equals. Now's a good. All right, so in this problem, we isolated your x plus 3 to the 4/3 by subtracting 4 and dividing by 2. And then you raise each side to the reciprocal of 4/3, which is 3/4. And you solved it, and you got x equals 5. And then you substitute back in to check your answer. Okay, in number 5, you already had your x minus 27 isolated, so you just raised both sides to the 2/3 power. And you got x minus 27 equals 16? Is that right?
Yes.
Okay. And then add the 27. 43? Okay. All right, and then you had to check. So I had 43 minus 27 to the 3/2 equals 64. 43 minus 27 is 16, right? And I get 64 equals 64, so it checked out, right? Do you understand, or do you have a question? Okay, as long as you understand, you're good. All right, 6, you had to get rid of your 8 first, so you subtract it, and you get negative 5. And then on this side, I have 4x plus 1 to the 1/2. What's the reciprocal of 1/2? 2/1 is right, but how could I even simplify that? Just 2, right? So you could write 2/1, but you might just want to write to the 2. When you do negative 5 to the 2nd power, if you did that on a calculator, you would want to put parentheses on it because it does turn positive. When you square a negative 5, it's negative 5 times negative 5, which should turn positive. So I get 4x plus 1 equals positive 25. Subtract the 1. 4x equals 24, and divide the 4. And you get x equals 6. So if you didn't get x equals 6, maybe what happened was after you subtracted the 8 and you got negative 5, you forgot that negative 5 squared is positive 25. So then we have to check. So 4 times 6 plus 1 to the 1/2 plus 8 equals 3. Oops, you can't even see that. All right, 4 times 6 is 24 plus 1 is 25. So I have 25 to the 1/2 plus 8 equals 3. And 25 to the 1/2 is 5. So 5 plus 8 equals 3. This is not working out, is it? You got 13 equals 3. So in this case, my solution doesn't work, and I don't have another solution, so what do I write? Very good. No solution.
Wait,
What?
he's gotten a solution.
You did? What'd you get?
We got negative 6.5.
So negative 6.5, when you put it back in, did it work?
Yeah.
It did? Okay, so first of all, I think the reason you got negative 6.5 is probably because you got negative 25 right here.
Yeah.
Right, but when you square negative 5, you want to put parentheses around it with a square outside, which should give you positive 25. However, if you got negative 6.5 and you substituted it back in and it worked, then that's still a problem because that should be a solution.
Yeah.
Right, so let's check that now. I'm going to just go to Desmos, okay? All right, so we're going to put negative 6.5 in. So I've got parentheses 4 times negative 6.5 plus 1 to the 1/2. All right, there's a problem here because we're doing the square root of a negative number and it's going to be undefined. It's actually, it will be a imaginary number I, but it won't work. But I appreciate you letting me know. Okay. All right, so this one is no solution. One more problem. You ready? The sales of a certain product after an initial release can be found by the equation S equals 19 square root of 4t plus 46, where S represents total sales and t represents the time in weeks after release. How many weeks will pass before the product sells 160 units? So is 160 units going to be S, total sales, or T, time in weeks? S, right. So S equals 180. All right, so I put the 160 for the S, and now I'm going to subtract the 46. All right, so I'm getting 114 equals 19 square root 40. And then how do I get rid of the 19? Divide it, okay.
Oh, yeah.
Scarlett, did you already divide it for me?
Look at it. 6.
6? All right, Addie says, do we just square it? Is that right? Very good. And then I'm going to solve for t by dividing. So I found that t is equal to 9 what? So t represents what? The time in weeks, so 9 weeks. I am going to check it. $160 is equal to 19 times the square root of 4 times 9 plus 46. Let's see, that's gonna be 36, and square root of 36 is 6. Nineteen times 6 is 114. And it looks like it's working out.